Good afternoon. Thank you for joining. I'm Shreya, one of the TAs for this course on Essentials of Data Science with R. And today I'll be solving a few problems from week 7 and week 8 lectures. So before I get started, if you have any queries, please ask me. I am not able to hear you. I saw your mic unmuted.
Ma'am, I am asking for the 12th question of the assignment 7.
12th question of assignment 7. Alright, 1 second. This one?
Yes, ma'am.
This X-ray experiment? Alright. Fine. Okay, so the question says that in an X-ray experiment, assume that number of particles entering in the hole can be modeled by a binomial random variable, and assume that a particle is entering into the hole is 0.2. Assume only n equal to 100 particles are to be received. Exact probability using the normal approximation to binomial that 15 or less particles are received is how much? Okay, so x is your uh, number of particles entering, which follows a binomial 100, and p is 0.2, the success probability. Now you have to find out probability x less than or equal to 25. Okay, so how did you proceed? So in order to do that, first we have to convert everything to a z-score. So then that would be probability x minus, so if you are doing this thing, you have to write, this is the approximation that we are assuming, right? X plus 0.5 is less than or equal to 25. This is something that we want. So then now probability x plus 0.5 minus np by root over npq would be 25 minus np is how much? 100 into 0.2, so it will be 20, and npq is how much? 100 into 0.2 into 0.8, so this would be 20 into 0.8, so this would be 16. So this would be this minus 20 by root 16, right? So this would be probability z less than equal to 5 minus 0.5 by 4, right? So this would be probability z less than equal to, how much does this come to? This should be p norm 5 minus 0.5 divided by 4. Okay, 0.869, but it's not there. Okay, are we up the exact probability using Marmol approximation to binomial? 25 or less particles. So what is the answer that is provided?
Thank you, ma'am. I got it. I forget to put the adjustment 0.5 value.
Okay, but even then I'm not getting the correct answer. So I'm just looking at the probable mistakes that I could have made. So binomial.
Because in
Hmm.
middle of the solving this part, I lost my connection.
Oh,
So
okay,
I
okay. Okay, but yeah, you have to apply an adjustment factor, then only you are going to get it. But even then, my answer is not matching. So I just want to double check whether.
okay, because I also didn't get the answer. That's why I'm asking for the same.
Okay. Oh, all right. I think here is the problem. Instead of plus, I have to make a minus distribution. Yeah, this one. Sorry. Here is the problem that I made. So the approximation, if you are given this less than equal to thing, it has to be this plus 0.5. So it will be 5 plus 0.5 by 4, and that would give you the answer 0.915. Yes. So it
Ma'am,
is
which
this.
command have you used for
This
in
for this
our
one I have used p norm.
genome? Okay.
Probability z less than equal to q, you have to use p norm q. By default, it will take mean as 0 and SD as 1. That is
Okay.
what we want because this is a z score.
Okay, ma'am. Thank you.
Okay, all right. Any anything else? Any other problem?
Ma'am, in eighth assignment, I am having the problem in setting the limits.
Okay, eighth assignment.
Ma'am, concept eighth assignment concept for for continuous random variable for bivariate.
All right. Okay, this is the due date is still valid. So I'll
Okay,
solve similar problems. Maybe you'll get an answer to that.
okay, okay.
Okay, fine. So let me just start with this problem solving session. So here is one question which you can get. Which of the following alternatives can be an outcome of the command runif 7510? So if you go to your R console and you just click runif and do an F1, you would get a description of what it is. So the first one is how much you want, okay, the sample size. Then comes minimum and then comes maximum if you don't specify the order. So here I want 7 random variables, a sample size n should be 7, and the starting point of my distribution should be 5 and end should be 10. So this is already out of the scenario because it's definitely more than 7. 1 2 3 4 5, this is also out, not 7. 1 2 3 4 5 6 7, this is 7. 1 2 3 4 5 6 7, this is also 7. But then this is out because this 16.6 is does not belong to this 510 range. So the correct answer is option D. Alright. Okay. Let's suppose this one. If x is a normal random variable with mu mean 5 and variance sigma square 25, let phi denote the distribution function of a standard normal variable. Excuse me. Then the values of probability x less than 10 and probability x greater than minus 5 are what and what. Okay. So probability x less than 10. Now x is a normal distribution with mean 5 and SD also 5. Okay, because sigma square is 25. Got it? Yeah. Now this means probability x minus mu by sigma is less than equal to 10 minus 5 by 5. Okay, this quantity we call it z and it follows a normal 0 1, and CDF of a normal 0 1 is represented by this phi. Okay, so if I have probability z less than equal to 2, I will write it as phi 2. Okay, so this will be how much? This will be probability z less than equal to 1. So this is phi 1. Alright.
Can we apply p norms here also
Of
for
course.
the
Yes.
okay.
So this answer will be whatever you get here, it would be p norm of 1. Okay. Next thing is what to do if you want greater than. So so now you have what? You have probability x greater than equal to minus 5. So this means again probability x minus mu by sigma greater than minus 5 by 5. Okay. So this means probability z greater than minus 2. Which means what? 1 minus probability z less than equal to 2. So then you can write it as 1 minus phi of 2. Okay. So I think the options are a little bit different. It should be 1 minus 5 by 2. Now how will you calculate this in R? Two ways. If you want to calculate directly from here, you just have to use p norm minus 2, but this is very important. Lower dot tail equal to false. If you want to calculate from this step itself directly. But if you just want to give p norm, if you calculate from this step, you have to give 1 minus p norm 2. Essentially it's the same thing. If you just go to your R console and write p norm minus 2 lower dot tail equals to false, you get 0.9772. And if you don't give that lower dot tail, then you have to write p1 minus p norm minus 2 lower dot tail equals to false. Sorry, lower dot nothing. Lower dot tail equal to true by default. So this is 0.977. Okay. This is also 0.977. This is also 0.977. Is it okay? So whenever you have this distribution, let's say this is your Q, P norm Q default is going to give you this area, the area below Q. Okay, so if you want to find probability something greater than Q, you either have to do 1 minus P norm, because by default this case, or you have to specifically mention that lower dot tail equal to false. I don't want lower tail, I want upper tail. Lower tail means towards your left, and upper tail means towards your right. We want if this is the classic case where we want probability x greater than minus 5. So we wanted 2. We wanted this minus 5. This is your 0, or rather this is x, right? So x mean is centered around 5, and this is your 10. So we wanted the area under this, and also we wanted the area above this thing. Alright, I've drawn it to be a little symmetrical, but it's not so. This is 10 units to your left, and this is just 5 units. So this point will be somewhere close to here. Okay, 10. Got it? Any confusion, doubt? Alright. Okay. So similar question, x is a normal variable with mean 5 and variance sigma square is 25. So phi denotes the distribution function of the standard normal variate, then value of probability 15 less than x less than 25. So probability 15 less than x less than 25 would be probability x minus mu by sigma. If we want to do, then that will be 25 minus 5 by 5, and this will be 15 minus 5 by 5. Okay, now the signs would not change because sigma is always positive. Sigma is St, which is always a positive quantity. Alright, so then this would be probability 10 by 5, 2 less than z less than 24. Alright, so this means if this is my standard normal variable z, this is 2 and this is 4. I want this area, right? So how can I get this? I can get this total area till 4 and then I can subtract this area. So this one I can write as probability z less than 4 minus probability z less than or equal to 2. Okay, to be technically correct, less than 4 I want this area, and less than equal to 2 I must remove. This is true for any variable, be it discrete, be it continuous. Since z is a continuous variable, probability z less than 4 is the same thing as probability z less than equal to 4. Why so? Because since z is continuous, the point probabilities are 0. Right? So we can write this as probability z less than equal to 4 minus probability z less than equal to 2. So this would be your 5 4 minus 5 2. So how will we get this? For this we have to write p norm 4 minus p norm 2. This is the R command. So we'll find it out. P norm 4 minus p norm 2. So this is 0.00227. This one 0.0227. Is it okay? All right. So let's go here. Any doubt from the previous problems? No? Okay. Fine.
Ma'am, clear hai.
Okay, fine. I have just one request for all of you. Please interact with me because if the connection drops, I get to know very late. So, just to save time and effort, please interact. Alright, thank you so much. Okay, so we'll move on to this one. The power W dissipated in a resistor is proportional to the square of the voltage, that is W equal to CV square, where C is a constant. This is my relation. C is 3 and V is assumed to follow a standard normal random variable with mean 6 and standard deviation 1. Find expectation of W and probability W is greater than 120. Alright. So expectation of W will be equal to expectation of CV square. So that will be C expectation of V square. Alright, and this means C variance of V plus expectation of V whole square, because you know variance of x is expectation of x square minus expectation of x whole square. So instead of x, so if we want expectation of x square, we have to write variance of x plus expectation of x whole square. Alright, so this we can write as C. Now variance of V is what? V is a standard, so V follows normal, mu equal to 6, sigma equal to 1. So sigma square variance is also 1. So this is 1 plus expectation of V is how much? 6. So this would be 6 square. So then that would be, and C is a constant, C is 3. So this is 3 into 37. This should be 1, 1, 1, 1. Okay. So expectation of W is 1, 1, 1. Is this part clear?
Yes, ma'am.
Okay. Now I have to find what is the probability that W is greater than 0. Okay. One more thing I want to ask. Were you taught about chi-square distributions? I don't think so.
No, ma'am.
Oh,
Still no.
still not. Okay. Fine. So probability W greater than 120. This means what? This means probability CV square greater than 120. So this means probability V square greater than 40. Alright. Now let me find out the distribution of V square. Alright. So,
Yes, ma'am.
so V is how much? So let my Y be equal to V square. Okay. So then probability V square greater than 40, or
Ma'am, can't we do the square root here so that we can find the V, and after that we can find the Z?
yeah, so probability V square greater than 40, this means what? This means that probability either V is greater than root 40 or probability V is less than minus root 40. Is this part clear to you?
Yes, ma'am.
Some square is greater than 40. So let's say this is my equation. So this is an equation of a parabola. Okay.
Yes, yes, ma'am.
Okay, so this is what? This is y x square equal to 4ay something. So that means that this is something like this. Alright, where we have x along this thing and y along this thing. This is the parabola that we have. So y equal to 40 means if this is y equal to 40 and area above this thing, then x should be either this thing greater than root 40 or x should be less than minus root 40. So then this should be how much? This should be this should be probability V minus mu by sigma greater than root 40 minus 6 by 1 plus V less than minus root 40 minus 6 by 1. So this we can write at probability Z greater than root 40 minus 6 by 1 plus probability Z less than minus root 40 minus 6 by 1. So this one will be this one will be 1 minus phi of root 40 minus 6 plus phi of minus root 40 minus 6. So we'll just calculate what it comes. Okay, so we wanted this part, 1 minus this thing, right? So directly if I want to do, I will go p norm. SQRT is the definition function for square root. Okay, so SQRT 40 minus 6. Okay, this is what we want, but I am going to give lower dot tail equal to false. So I got then the first probability. This part I got it with this thing. Okay, 1 minus this thing I've already written. Now I'm going to write plus p norm square root of 40 minus 6, but there should be a minus over here, minus square root 40 minus 6. So the answer is 0.372. This one. Okay, so this is my correct answer.
Got it, ma'am.
Got it?
Yes, ma'am.
All right. So if suppose it was written v square, if you would have wanted probability w less than 120, then where the change should have been made? So till
Ma'am,
yeah,
lower dot tail equals to false.
no, the change would have been reflected here. Same thing would have come from here. It would probability w less than 120.
Yeah.
I will just solve it for you, just to clear the concepts a little bit more. So here we have, let's say, probability w less than 120. This would translate to, so if we just follow this pattern, it would be probability v square less than 40. Okay, so that
Okay.
would be either v minus root 40 less than v less than root 40. You just have to remember
Okay.
this curve and what it is that we want.
Step should be the same, but now the lower dot false part applied at the left hand side
This
part.
should be phi of root 40 minus phi of minus root 40.
Minus 40. Okay.
Okay, this thing, this is root 40 and this is minus root 40. We want this area. So we'll calculate this much and subtract this much. So here in both the cases, no lower dot tail equal to false is required. This would be P norm root 40 minus P norm of minus root 40. That's it. Is it okay?
We simply applied minus root of 40. There is no need to apply the lower dot tail equals to false here,
No,
because we,
because by default we are getting lower dot tail equal to true.
okay, we are doing subtraction here.
Whatever comes here, no, you have to
Hmm.
correlate it with this graph. If we
Okay.
want the area between, then how
Hmm.
can we do it? If I, by default, P norm is going to give me the entire area below root 40. From there,
Hmm.
if I subtract the area below minus root 40, I am good. I'm going to get this thing. But what
Okay.
happened in the previous one? Previous one we had greater than root 40 and minus. So in this one, the area was this thing. Let's say this is your curve. This is root 40. This is your minus root 40. So we wanted this area and this area.
Okay.
Alright. What you could have also done was that since this is symmetric, you could have also written P norm root 40 lower dot tail equal to false. Then you would have gotten this area and then multiplied it into 2. That would have also worked. Like here, if you do a P norm of square root where's it? Square root of 40, okay, here square root of 40 P norm lower dot tail equal to false will give you this area. Lower dot tail equal to false. You got, then whatever I have written, you got this right hand side, this part, and that since it is a symmetric distribution about 0 into 2, root 40 minus 6, sorry, should be root 40 minus 6. Why is it not coming? Yeah, probability V greater than root 40, V less than, oh, so greater than root 40 minus 6. That's what I wrote. Greater than root 40 minus 6. P norm lower dot tail equal to false. Then why am I not getting it?
Ma'am, why we are doing the twice of this thing? Uh, if we
Ah,
got
right, right.
the, yes,
Yeah,
if we
of
got
course.
the value of under root 40, then symmetry means the same will be applied for the minus root 40.
No, here we cannot do that because I'll tell you where we are facing this issue. If it was
Mm.
only minus, this is the distribution of z symmetric across 0, right?
Okay.
But
Huh.
here the points under consideration are root 40
Mm.
minus 6 and minus root 40 minus 6. So if we take
Okay.
minus common, this is root 40 plus 6. So this point and this point are not the same. Thank you for pointing this out. Like this is also another thing. See here, if you have something like this is my standard normal variant. This is Z and this is, let's say, P, and this is minus P. Then this is symmetric about 0. I can just find this out and do a 2 into this area A and get my answer. But what happened in this case, why that is not possible, is because here we had, in this case, this is my Z distribution. V distribution is centered around the point 6, but Z distribution, which is the center is 0, I wanted root 40 minus 6 and minus root 40 minus 6, which is essentially minus taken if common plus 6. So this area and this area, they are not equal because this is not P and this is not minus P. Got it? So this approach will not work. If we forget to look at, if we just assume that Z is symmetrical and do a minus and of the transformed variable and do a plus, we would land up at the wrong point. Okay? Is it okay? Any confusion? So in such cases, it is best not to go and do a 2 into of these things. It is better to write it down explicitly and then just use the software to go and get the values, until and unless you are 100% sure that the symmetry around 0 can be utilized. Is it okay? All right. Moving on. So the data indicates that the monthly supply of electricity in a factory is a normal random variable with mean 12.08 and standard deviation 3.1. Probability that the total electricity supply in next 2 months will exceed 25 million watts is how much? So probability monthly supply is Z, or let's say X, would be greater than 25. This is what we want. So we can write this as X minus mu by sigma greater than 25 minus 12.08 by sigma is 3.1. So this means probability Z greater than 25 minus 12.08 by 3.1. This is P norm of this variable and lower dot tail equal to false. Okay, so we'll do that. So this is what P norm (25 minus 12.08 divided by 3.1) okay, lower dot tail equal to false. This is 1.53 into 10 to the power minus 5. Uh, oh, okay. Here they have said that the monthly supply of electricity is a normal variable. Okay, so probability total electricity supply in the next 2 months will exceed 25 million watts. So this is not the formulation, because it is mentioned monthly supply and we want a total for 2 months. So let's say y equal to x1 plus x2. x1 follows normal 12.08 and 3.1, and x2 follows normal same thing 12.08 and 3.1. okay, this is the distribution for first month, this is the distribution for second month. So y, since it's a linear combination, it will also follow normal. Okay, and the mean will be 12.08 plus 12.08. okay, and this is sigma square 3.1 square. So, and this would be 3.1 square by 2, because variance of y is variance of x1 since they are independent, variance of x2. So this would be 3.1 square plus 3.1 square. So it would be 2 into 3.1 square. Alright, so y would follow a normal 24.16 and sigma would be how much? 2 into root over 2 into 3.1. Alright, now the probability that y would exceed 25 this would be probability y minus 24.16 by sigma, that is root 2 into 3.1, which is greater than 25 minus 24.16 by root 2 into 3.1. So here we will give p norm, this one, and lower dot tail should be false. So let us just do that. So this would be 25 minus 24.16 divided by 3.1 into square root of 2. Okay. Alright. So this is 0.424. This is the answer. Okay, this would be 0.424. Got it? So the keyword here was monthly supply, and we wanted in next 2 months. Similarly, if we would have gotten 3 months, then it would have taken x1 plus x2 plus x3. So the general result is that if xi follows normal mu I sigma I square, then xi x1 plus x2 plus xn, where it is given, and it is a very important given, that xi's are independent. Okay, here one strong assumption is that supply in the first month is in no way dependent on the supply on the second month, or the supply on the second month is not dependent on the supply on the first one. Okay, this is a strong assumption. So if that holds, then this sum will also follow a normal with mu1 plus mu2 plus mu n, and variance will be sigma 1 square plus sigma 2 square plus sigma n square. Okay, given they are independent. If they are not independent, then there would be additional terms apart from these square terms in the sigma square, in the variance. Alright, I have been telling this repeatedly for a few classes now, so please keep this in mind. Okay, you have to assume that the xi's are independent for this sum of variance of sum equal to sum of variances to hold. Is it okay? Any doubt? Alright, let's say this one. Suppose length of a screw manufactured by a machine are normally distributed with mean 10 centimeters and variance this 1 centimeter square. If for a given application length of screws must meet the requirements to fall between 9.9 and 10.2, what proportion of the screws will meet this requirement? So we have to find out probability. X is the length. Okay, x is the length, and x follows normal 10, and variance is sigma square is 0.01. So we have to find out 9.9 less than x less than or equal to x is 10.2. So this would be probability 9.9 minus 10 less than equal to x minus 10 less than equal to 10.2 minus 10. This would be probability 9.9 minus 10 by square root of 0.01 less than equal to x minus 10 by root over 0.01 less than equal to 10.2 minus 10 by root over 0.01. So this would be probability 9.9 minus 10 would be minus 0.1 by 0.1. Minus 0.1 by 0.1 less than equal to z less than equal to, this would be 0.2 by 0.1, 0.2 by 0.1. So this would be probability minus 1 less than equal to z less than equal to 2. This would be phi of 2 minus phi of minus 1. So this would be p norm 2 minus p norm minus 1. So we'll just do that. P norm 2 minus P norm of minus 1. So that would give you the answer 0.818. Okay, this would be 0.818. Is it okay?
Yes, ma'am.
Okay, fine. Which of the following is the correct command in R to compute the probability P15 less than x less than 25, where x is normally distributed with mean 5 and variance of 16. So what would be the answer? So you have to note, in P norm the input is not variance but SD. Okay, so your SD field should be root over 16, that is 4.
C.
Alright, yes. So what we are doing here, we are taking P norm Q. P norm standard is Q equal to 25, then we give mu, then we give SD. And we wanted this area, if this is centered around 5, we wanted that it falls between 15 and 25, this area. So calculate till 15 and subtract from the left hand side to till 15. So it will be P norm 25 minus P norm Q equal to 15. Mu should be 5, SD should be 4. Okay, good. Alright, so the question here says, in a radioactive experiment, assume that the number of particles received by the target can be modeled by a binomial random variable, and assume that the probability that the particle is received is 0.1. If n equal to 50 bits are to be received, the exact probability using normal approximation to binomial that 2 or less particles are received. This is also a similar question. So we want x less than equal to 2. Now normal approximation would be probability x less than equal to 2 plus 0.5. So then this we can write as probability x minus np by root over npq less than equal to 2 plus 0.5 minus, now what is my np? X is a random variable following binomial 50 and p is 0.1. So n is 50, p is 0.1, np is 5 and npq is 50 into 0.1 into 0.9, so that would be 4.5. Alright, so this one would be 2 plus 0.5 minus 5 by root over 4.5. So then this would be P norm, this thing, 2 plus 0.5 minus 5 by root over 4.5. So it should be P norm 2.5 minus 2.5 by root over 4.5. We'll just calculate. So it should be P norm minus 2.5 divided by square root of 4.5, and that would be 0.119, this thing. So the answer is 0.119. Got it? Alright, moving on. In a large computer network, user log in to the system, which can be modeled as an exponential distribution with lambda equal to 1 logins per minute. What is the probability that there are no logins in an interval exceeding 4 minutes? Okay, so user login to the system, lambda equal to 1 logins per minute. So then in that case, the rate of login is 1. Okay, and we have to find out no logins in an interval exceeding 14 minutes. What does that imply? So if we say x is the time in minutes from start until login. Okay, until first login, let's say. Then x is following exponential with rate 1. Alright, so then x is following exponential where lambda is 1 by 1, that is 1, following exponential lambda equal to 1. So then probability no logins in an interval exceeding 4 minutes is that probability x greater than 4. The first login happens after 4 minutes. So to do this, how can we do this? We can write this as 4 to infinity lambda e to the power minus lambda x dx. So it should be 4 to infinity 1 into e to the power minus 1 into x dx. So this is 4 to infinity e to the power minus x dx, and that we'll write as e to the power minus x minus 4 to infinity. So this, if we put infinity, it will be 0 minus of, if we put 4 over here, minus e to the power minus 4. So this would be then e to the power minus 4. Okay. So we could write this like exp minus 4. This is also possible, 0.018. Or if we want to find it out using the distribution, if we want to skip this calculation, we want to find out probability x greater than 4. So in order to directly do that, what can we write? Here we can write p exp, q equal to 4, rate equal to 1, okay, and lower dot tail equal to false. So we'll write this p q e x p. If we do a control, if we do an f1 function 1, we would get, sorry, alright, but the help button should come over here. I don't know why it's not coming. F1, it's not working. Yeah, here. Oh, I wrote it PQEXP, sorry, my bad. Yes, so if you do a F1, here the documentation will come. Okay, so here what do we want? Probability x greater than, we want probability x greater than 4. So then Q is 4 and rate we have to give 1 and lower dot tail should be false, and then we would get the same thing, 0.018. Okay, so one more thing that we should remember in case of exponential distribution is that in R the entry is always rate. Okay, So if we have something like this, x equal follows exponential lambda, usually how do we write fx as lambda e to the power minus lambda if x greater than 0 and 0 otherwise. Okay, so rate in that case is 1 by lambda. So if you are given this parameter, instead of specifically it being mentioned in the, like in this question it was mentioned what is the rate, 1 logins per minute, so we could directly enter this. But if something in the inverse rate is given to you, then while entering in r you would have to give 1 by. For example, if very theoretically this comes that x follows an exponential with lambda equal to 3 and the parameterization is 3 to the power minus 3x, then in the rate column you have to enter 1 by 3, okay, and that is 0.33 when you are giving the input in r. Alright, this is one small thing that you should be very careful of. Alright, am I clear?
Yes, ma'am.
Okay, fine. Moving on. So same question, in a large computer network, user logins can be modeled as a distribution with mean 4 logins per minute. Okay, yes, so 4 logins per minute is the mean. So here lambda is what? Lambda is 1 by 4. Okay, so what is the probability? Number of logins per minute are between 6 and 9. So we want probability x between 6 and 9. So what will we write? PEXP9 rate equal to 0.25 minus PEXP6 rate equal to 0.25. The exponential distribution looks something like this. Okay, so from 6 to 9, this area we want. So calculate area till 9, subtract till 6. So if we do that, how much do we get? PEXP q equal to 9, rate equal to 0.25 minus PEXP6 rate equal to 0.25. So it is 0.117. This one, the first one. This is 0.117.
Get it, ma'am.
Alright, okay. The last one was this one, right? 0.183. Fine. Moving on. So here the same thing. User login to the system is modeled as an exponential with mean this thing. So rate will be
1 by 4.
1 by 4. That is 0.25.
B.
Which of the following command is used to generate 8 random observations? That would be B. Alright. Okay, so now let us move on to some WEET 8 concepts. So we learnt about bivariate distributions for discrete random variables and bivariate distribution for continuous random variables, and also we learnt about covariance and correlation. So let's say I have a drug, okay, and I want to test its efficacy. Alright, and I'm going to give this treatment to a group of people who are either diseased and who are not diseased. Okay, so what I'm going to do is that I have two categories of people who are diseased and not diseased, and to some in each of the category I'm going to give drug A, and to others I am going to give placebo. Okay, that is not the drug itself but something uh, which will not in any way affect the person. All right, so if I have such cases where I have two variables that I want to look at simultaneously, that is the treatment and also whether they are diseased or not. Okay, so disease yes no, treatment yes no. Then the table that I have like this is usually what we called as a contingency table. This is a 2 cross 2 contingency table, right? So if let's say I have total 100 individuals, out of which diseased is, let's say the incidence of disease is like 20% of the population is diseased. So my column would be, if I have 100 total individuals, 20% is diseased. Okay, so this would be 80, right? And I am administering this treatment irrespective of your diseased condition in a 40-60 manner. Okay, so 40% I am going to give the disease, the treatment, and 60% I am not going to give this. Okay, so then these are actually my marginal distributions. Okay, in the margins, and the, let's say how many, let's say 10 people have the disease and they also receive this treatment. So if we say 10 10 30 50, something like this. Okay, so then probability that this diseased person is receiving treatment, that will be decided by, that would be 10 by 100. Okay, so then that is actually what we call a joint distribution between x and y, between the diseased condition and treatment. So what I want to say is that if you have two variables x1 and x2 and they have certain levels, let's say L1, L2, L3, and here let's say M1, M2, M3. This is also a discrete variable. This is also a discrete variable. Now if you want to see how they are acting together, then in order to visualize the joint distribution, we need contingency tables of this sort. Okay, and then if we add it up in the margins, these would actually give me my marginal distributions. And we could also have some conditional distributions. Okay, so we'll solve a few problems and then we'll be able to understand what exactly do we mean by this marginal and this thing. All right, so let's say I have a data, okay, where I have been given let's say uh, a car's data. Okay, I am testing, the question is I am testing let's say 200 cars, okay, with two types of drivers. All right, and the cars follow 3 levels. Let's say the first level is, let's say, small cars, medium sized cars, and big cars. Alright, and drivers have 2 levels. One is beginner and one is advanced. Okay, so what I am going to do is that I am testing 200 cards with these things. So the contingency table that I have, let's say here I am looking at the driver experience. It could be beginner or advanced, and this side I am looking at the cars given. Alright, small, medium and big. So let's say I have so total number of cars that I'm going to test is actually 200. Alright, let's say out of these 200, 15 people are beginner and they are testing on a small car. Okay, let's say 30 people are advanced but they are testing on a small car. Here again I have, let's say, 60 people who are beginner but testing on a medium sized car. Alright, and 40 people are advanced but they are testing on a medium sized car. Similarly, here how many do I have? "25 people are beginner but they are testing on a big car, and this would be 200 minus 100, this is 15, 40, 70, so 30. Alright, so then this table is a table of the absolute frequencies. Alright, now if I want to find out the marginal distribution of this thing, how many, what of the number of cars, then what do we have to do? We have to get to this one. Okay, this is the marginal frequency that we want. So how many are testing on small cars? That would be 45. How many are testing on medium sized cars? That would be 100. Okay, and how many are testing on big cars? That would be again 55. Okay, so that sum total is coming up to 200. Is it okay? Here again,
Yes, ma'am.
what do we have? 40, this is 100, this is also 100. So the sum total is also coming to be 200. Okay, this is a table of absolute frequencies. Alright,
Ma'am, please tell me the concept of expectation of conditional probability.
okay, I'll come to that.
Okay.
So first let me tell you about these frequencies and how to translate it to probability. So this is your frequency distribution. Now if you want the probability distribution, if you remember Probability is approximation of relative frequencies, right? So if you have to convert this to relative frequency, what you have to do is driver's experience is this thing. Let's say beginner, and this is advanced. This is your small, this is your medium, this is your big. So if I want a table of relative frequencies or the probability distribution, in that case, if I want a 2x2 joint distribution or probability distribution, I need a table of relative frequencies. So what will I do for relative frequencies? I am going to divide each of these frequencies by n. Okay, so each of ni should be divided by n. Here my n is how much? 200. Alright, so this would be 15 by 200. This would be 30 by 200. This is what? 60 by 200. This is 40 by 200. This is how much? This would be 25 by 200. And then this would be 30 by 200. So if we just add this up, this will again be 100 by 200. And this would also be 100 by 200. This would be 45 by 200. This would be 100 by 200. And this would be how much? 55 by 200. Okay. So if I ask somebody that the probability that the driver would be beginner and that car would be big is how much? That would be this thing, beginner and big, this probability. This would be 25 by 200. Is it okay? Is this part clear? If I want to find out, let's say the driver should be advanced in experience and is testing on a medium car, what is that probability? That would be 40 divided by 200, 1 by 5. Okay. This is the joint probability. All of these are joint probabilities. That is probability x equal to x and y equal to y. Now if I want the, excuse me, yeah. So, yeah, where was I? I was looking at the marginal distributions, right? Yes. No, I was looking at the probability distributions. Now, if suppose somebody asks for marginal distribution, that is of the driver experience, let's say. Okay. So then the marginal distribution of driver experience is that beginning how many? It is half and advanced also is half. So x beginner, that probability is half, and x advanced probability is also half. Okay. Now if I want the marginal distribution of, let's say, cars, then I would have small, medium and big. So that would be that probabilities would be along these axes. So it would be 45 by 200, whatever that is. This would be 100 by 200, that is half. Medium will be half, and this will also be 55 by 200. This will be 55 by 200. Alright. Now, these are the marginal distributions. You can see all these probabilities will add up to 1. This will also add up to 1. This will also add up to 1. Now, I would want to emphasize on conditional probability. Okay. So, conditional probability is that probability of testing on a car y equal to x given the driver is beginner. Okay. So, that would be how much? You are testing on a small car, you are testing on a medium sized car, or you are testing on a big car. Okay. Probability y equal to x given y equal to small y, let's say, given x is beginner, x is your driver's experience. So, given that you are a beginner, so this would be how much? This would be whatever actually this means. Probability y given x means probability of y equal to y and x equal to x by probability of x equal to x. So, here one second. So, here the probability that he is a beginner is how much? From here, beginner is half. Okay. So, then this would be half. And beginner and small, yeah, one second. Okay. This is probability y given x, y equal to y, x equal to x by probability x equal to x. So, that would be 1/2, and y equal to y, x equal to x is give what is the probability that the driver is a beginner, and comma means and or intersection, the car is small. So, that probability is how much? That is beginner and small, 15 by 200. Okay. So, this is 15 by 200. So, this probability is 0.15. Similarly, probability that the car is a medium sized given that x is beginner would be how much? That would be this part, 60 by 200 divided by half. So, this would be 60 by 200 by half. So, this would be 0.6. Okay. And this one, probability that the car is a big one given x is beginner is, it should be how much? It should be 25 by 200 by half. So, it would be 0.25. Okay. So, note all these also add up to 1. Is it okay?
Yes, ma'am.
Alright. So, is your doubt clear or there's still confusion?
Ma'am, for continuous bivariate.
Alright. Alright.
Bivariate.
Got it.
Asking
So, you
for-
don't have any problem for discrete distributions.
Yes, ma'am.
Alright. So, anyway, this is how, if you are given a data set where, let's say, you are the data is given to you in this format. I'll come to the continuous setup in a while. So if the data is given in this format, x and y, let's say you are given car 1, driver is a beginner and the size is small. Car 2, driver is advanced and it's a small. Like that car n, the driver is a beginner but it's a big sized car. Okay, so if you just give a command table x and y, you are going to get that raw frequency contingency table. Okay, so then you just have to categorize it into levels and count the numbers that you have and accordingly fill in these boxes and then calculate the margins with the add margins code that is given, and then from there you can easily get the marginals and the conditional distributions. Okay, now let's say you have this thing. I'll come to your conditional probability question. So here, from here I have, let's say, conditional probability y given x. I have x equal to beginner. Alright, let me assume that y is a, so this one probability y equal to y given x equal to x would be something here. This should be some y1 with probability p1, y2 with probability p2 and y3 with probability p3, right? Like for example here it was small with probability 0. This is your y and this is your p. Medium with the probability this thing and beginner with the probability this thing. Now if you code it into, let's say this is your level 0, this is your level 1 and this is your level 2. Alright, so if you want to find expectation of y given x, then what do you have to do? You have to do 0, 0 into this probability p1, okay, plus 1 into probability p2 plus 2 into probability p3. Alright, that would give you the conditional expectation.
Okay,
Similarly, you can find conditional variance. That would be expectation of y square given x minus expectation of y given x whole square. So 0 square into p1, 1 in plus 1 into p2 plus 2 into p3 minus whatever expectation, that square. So in a discrete case, this is how you should get to a conditional probability. So what happens if we move on to a continuous case? So we'll try to find from this example. So let's say x and y are two random variables with joint probability distribution this. Okay, find probability xy belongs to A, where A is xy less 0 less than x less than 0.5 and 1 less than y less than 2. So probability 0 less than x less than 0.5 and 1 less than y less than 2, this would be double integration 3 by 5x x plus y dx dy, x from 0 to 0.5 and y from 1 to 2. Alright, so if we solve this, this is 1 to 2, 0 to 0.5, 3 by 5x square plus 3xy by 5 dx dy. So we can do this in this manner. So this will be 1 to 2, 0 to 0.5, what was that? 3 by 5x square plus 3xy by 5 dx dy. Alright, so this will be 1 to 2, 3x cube by 3 into 5 plus 3 x square by 2y by 5 from 0 to 0.5 dy. So if we just substitute, then this would be 1 to 2 x cube, that is 0.5 cube by 5 plus 3 by 10 0.5 square y dy. Okay, so this will be 1 to 2. 0.5 cube by 5 is how much? Zero point 5 cube divided by 5, 0.025. So this is 0.025 plus, this will be 3 into 0.25 by 10. This is how much? 0.075. Okay, so this would be 0.025 plus 0.075 y dy. So that would give you 1 to 2 0.025 plus 0.075 y dy. So this would be 0.025 y plus 0.075 y square by 2, 1 to 2. So this would be 0.025, 2 minus 1 is 1, plus 0.075 into y square 4 by 2 minus half. So this would be how much? 2 minus half is 1.5. 0.025 into 1.5 into plus 1.5 into 0.075. So we just find it out. 0.025 plus 1.5 into 0.075. Okay, so that would be 0.1375. So this would be equal to 0.1375. All right, is it clear?
Yes, ma'am.
Okay, and that would be something in fraction that we have to see what it is. Now if we want something like this, here again the same thing, fx and fy, two random variables with the joint probability distribution this, find marginal densities of fx and fy. So fxx would be integration over y fxy, okay, whatever is the range. So here marginal for x fxx would be integration of dy over y, we should integrate, like using,
Ma'am, please solve one of the type question where
sorry,
we are finding the marginal density. Ma'am, please solve one of this type question where we can find the marginal density.
yeah, that's what I'm doing. This is the question,
Okay,
right?
okay.
If you are given a joint probability distribution, how will you find the marginal probability? So I just want to
Yes.
tell you the how you can relate, I mean how you can remember what you have to do in order to get a marginal distribution. So if you see in this driver's example, if you wanted this beginner and advanced, you did a sum of across the other variable, right? If you wanted a distribution of advanced, you just took the sum across all cars. Similarly here, if you want to find out the marginal distribution for x, you have to integrate over y. Got it?
Okay.
Okay. So
Yes, ma'am.
now fxy is how much? 2 by 3 x plus 2y. We have to integrate over y. What is the range of y? Y ranges from, y can take values between 0 and 1. So you would have 0 to 1. Now we'll solve this. This is how much? 0 to 1. 2 by 3 x plus 2y dy. Okay. So then what will this be? 0 to 1, 2 by 3x plus, what is this? 2y dy. So this would be 2 by 3 x 0 to 1 dy, because in that case x is a common, we are integrating over y, right? This is a constant term, so it will come out, plus 0 to 1 2y dy. So this would be 2 by 3x y would be from 0 to 1 plus y square 0 to 1. So this would be how much? This would be 2 by 3x, 1 minus 0 is x, plus y square, 1 square minus 0 is 1. Okay. So the marginal distribution will be how much? It will be 2 by 3x plus 1. Okay, one more thing. This is 2 by 3 is common here, right? So this is 2 by 3 common, x plus 2y. So here also we would have 2 by 3. Okay. So this would be 2 by 3 x plus 1. So then the marginal of x, fxx, is 2 by 3 x plus 1, and the range of x is, x can range between 0 less than x less than 1. 0 less than x less than 1 and 0 otherwise. Okay. So which one is matching? This one. This is the marginal distribution of x. Alright. Similarly, if we want the marginal of y, what we have to do in order to find out marginal of y, we have to do fxy but integrate over x. Got it? So here also we will see 2 by 3.
Yes.
What is the thing? X plus 2y. X plus 2y dx. And what is the range of x? 0 to 1. So this would be 0 to 1. So again, if we do this, this is 2 by 3 x plus 2y, right? So 2 by 3 will take common. This would be, 2 by 3, if we just take it out, we have integration 0 to 1 x dx plus integration 0 to 1 2y dx. Got it? In that case, because we are integrating over dx, y is a constant, so that will come out. So then what do we have here? We have 2 by 3 x square by 2 0 to 1 plus 2yx 0 to 1. Okay. So this will be 2 by 3 into half plus 2y. So this would be how much? This would be 1 by 3 plus 4y by 3. So if we take 1 by 3 common, it would be 4y plus 1, and the range of y would be 0 less than y less than 1, as is given here. Okay. So marginal of x was 2 by 3. What was the marginal of x? Marginal of x was 2 by 3 x plus 1. Sorry, I'm extremely sorry in marking this. This is not the one. So the correct answer is this one. 2 by 3 x
D.
plus 1 d.
But
Yes.
yes.
And this is 1 by 3, 1 plus 4y. Got it?
Yes, ma'am.
Okay. Now once you have this, next question is what will I do when I have conditional distribution? Right? So,
Yes, ma'am.
yes. So, same question, same PDF. Now, find the conditional density of x given y equal to y and probability x less than equal to half given y equal to half. So, what to do? Now, conditional distribution, if we have to find out, then we should, if we remember, f of xy by, we want x given y, so it should be fy of y. Alright?
Yes, ma'am.
Okay. Now, here, what we want is
Fx joint
the
probability
joint
function upon.
probability between this one and this one. So, we'll have to first find out the conditional distribution. So, fxy is this thing and fyy is how much?
We just calculated.
Yes. So, fyy is 1 by 3 4y
Four.
plus 1, 0 less than
Yes.
y less than 1. Okay, and this is what fxy is 2 by 3 x plus 2y. fxy is 2 by 3 x plus 2y. So then f of x given y would be 2 by 3 x plus 2y by 1 by 3 4y plus 1. So
Yes,
that
ma'am.
is what? That is 2x plus 4y by 1 plus 4y. And x given y, we have to specify the range of x, 0 less than x less than 1. So this is your conditional distribution, that is this one. Okay, for 0 less than x less than 1.
Okay, ma'am.
Got it? Now, now the query is probability x less than equal to half given y equal to half. Okay, so how do I get there? So we have to find out probability x less than equal to half given y equal to half. So then we have the conditional distribution here, 4x plus 2y by 1 plus 4y. So here, once we have this, given y is half, probability x less than equal to half given y equal to half would be, what is the range of x? 0 less than x less than 1. So we have to take 0 to half. Here we will put the values of y. So it is 2x plus 4y plus 1 plus 4y, right? 2x plus 4 into half by 1 plus 4 into half dx. Okay, so it will be 0 to half 2x plus 2 by 2 plus 1 as it is 3 dx. So that would be 0 to half. Here we have what? 2x plus 2 by 3 dx. So this would be 1 by 3 x square plus 2x 0 to half, right? This will be 1 by 3 1/4 plus 2 into half, that is 1. So this will be 1 by 3 into 5 by 4 and that would be 5 by 12, and that is the answer.
Yes, ma'am. Got it.
Got it? I hope
Yes,
this is
ma'am.
clear. So whenever you have something, point to note here is that don't remember that okay, point probability should be 0 for any continuous distribution, so this will not exist. It is not like that. You would have to, if you are given some equal to value, what you have to
Hmm.
do is you have to find out what is the conditional distribution and put the value of y there, substitute it there in case you have
Oh,
equal to. If you don't, well and good, you just have to do, let's say if I have probability x less than equal to half, a variant of this sort of problem, let's say probability x less than equal to half given y less than equal to half, something like this. So then what do you have to do? You have to find out x less than equal to half, y less than equal to half, and from the CDF of y, from the marginal of y, find out probability y less than equal to half. Get this, and you'll get the ratio would give you the answer.
okay.
Okay. So for this, you if you are given the bivariate, from there you have to get the marginal, and from there you have to get the this value. And this one you have to see the interaction, both of these hold. So you have to see the range over which both of these hold, and then find out. All right.
Okay.
Okay.
From the for the given range, we have to select the what question required. We have to put
Exactly.
that formula.
Yeah.
Okay.
So from this range, we have to decide whatever is given. Okay, x less than half and y less. If let's say if you, in this case these are separate. Sometimes you might get 0 less than x less than y less than 1, something like this.
Yes, ma'am. This is very confusing. In
Huh.
this, how to get this range?
Huh. So
Select the range.
so if you have something like this, let's say where 0 less than x less than y less than 1, some fxy. Okay. So if you want to find out fy, you have to
Hmm.
integrate over range of x. So x at
Yes.
that point ranges from 0 to y.
Okay.
Okay. And if you want to find out fx, then you have to calculate you have to see the range of y. So then
Why?
that case it will be x to 1.
X to one. Okay.
Okay. So if you have
Okay.
relations between these three, you would have to find out what x lies between and what y lies between, and then find out. You can even do it graphically. Let's say this is your x equal to y line. Now you have to find out, I mean, from the graph also, if you are pictorially, if you feel that that is better for you, go ahead and you can also use that to formulate your hypothesis. All right.
Ma'am, please explain a little on graphical
Okay, let's say
graph.
here both x and y has to lie between 0 and 1. So it has to be 0 to 1. It is also 0 to 1. All
Okay.
right. So if 0 less than x less than y less than 1, then which side of the curve are you interested in, let's say?
Ma'am, for X,
For we want
take.
x less than y, right? So here if I am 2, then this is 2, and here y is 1. So so here x is 2, y is 1. So x is greater than y in this case. So I am the area that I'm interested in actually is this part. Is this clear to you?
A bit confusing.
Okay. Let's say
Okay.
here this is x equal to y line, right?
Okay.
So
Yes,
here
ma'am.
if your x is 2, so anything below this line your y it should be less than 2, right? So let's
Yes, ma'am.
consider this point. So here you have x equal to 2 and y equal to 1. So this condition x is greater than y. So this is not
Okay.
satisfied. So this is not, the lower part is not your area under consideration.
Okay.
But
So
if you
we
go
will
to
select
upper
the
part, so if x is 2 here, here your
okay.
y will be 3. So x less than y is satisfied. So then this upper triangle is your area of concern.
Okay.
Okay, so if you want to verify that this is actually a PDF, what do you have to do? You have to doubly integrate over fxy, right?
Yeah,
Where
right.
your x will range from y to 1. Let's say this is your y to 1, or let's say your y is ranging from, this is your y axis, 0 to 1, and your x is ranging between 0 to y. X can be, let's say, let us fix y, then your x can range from 0 to y, and you are integrating over this area.
Okay, ma'am.
Okay, so if you are confident doing it graphically,
Mm.
you can give it a try, or you can just look at these inequalities and set your limits.
Okay.
All right.
Thank you, ma'am.
Okay, so I think yeah, so this is one experiment was conducted over a sample of 300 patients to judge the duration of medicine that remained effective, set of n paired observations. So xy, such 300 pairs were obtained on the age. Let's say this is age, and this is number of hours. Okay, so if you have such 300 such observations, then the value of this thing, where x denote age and y denotes time and n is the number of observation, this is nothing but what your covariance means. Okay, covariance between x and y. So you just go to R and calculate the covariance x and y, where x and y you enter as vectors, and you would get the answer. Alright, and if you want the value of the correlation coefficient, if you get covariance xy by root over variance of x, root over variance of y, you can either calculate this, or you can just calculate correlation between x and y in R directly, and you would get the answer. Is it
Okay.
okay?
Okay, ma'am.
All right. So I think I've come to an end of today's session. If there's anything else you want me to, you want to understand, any confusion, you can ask me
Ma'am, so far clear.
now. Okay.
Things are clear.
Okay. All right. So one more thing I would like to point out with respect to examination pattern. So I saw this
Yes.
Google conversation. So here it is mentioned that the exam will be for 3 hours, and only MCQs will be asked. The software won't be provided, but it is imperative that you learn the commands and what it does, so that if questions like that come, that what is the command, or what is the output that is generated if you type this, or what is the command that is generated if you do this, if you'll be able to answer those kind of questions.
Means we have to learn the commands, but
Yes.
software is not provided to
No, the
us.
software won't be provided. So whatever is mentioned in the course material, and also
Mm.
whatever you would learn by yourself, either from these sessions or from anywhere else, just have a habit to know the syntax, what it is doing, in which
Okay.
order. Like for the distributions, the order is very important, in which order you are getting the you are putting the inputs. The first one has to be sample size if you are using R, but if you're using
Mm.
P, the first one has to be quantiles. Those kind of
Okay.
nitty gritties. Just take a look at them and keep those in mind. That
Ma'am,
might be helpful.
command can become in multiple questions, but questions uh, by which we are in which we are using the commands will not come.
Maybe for calculations you would be provided with a calculator. I don't think you are supposed to carry your own calculator, but you can just get it confirmed. Anyway, the system that you would be working on, that would have a scientific computer, a calculator installed, hopefully. So you can do your calculations there. But like for example, if you wanted that exponential thing, you would not be able to do a QXP on spot. You would have to
Ma'am, one
derive it.
one more query. Ma'am, is it compulsory to get submit the eight assignment? Because I go through the QA part and someone asked that it is required. We are required to submit at least of eight assignments.
I am not very sure about this thing. You can
Okay.
maybe mail the NPTEL team for this thing.
Okay.
Okay? Alright. If no more questions, thank you so
Okay.
much for joining. I'll see you next week.
Thank you very much, ma'am.
Thank you.